Hello everyone. In this video, we'll be dealing about Fourier transforms. That's your module 5. Okay, the main topics coming under this section are Fourier transform of a function f of x, Fourier sine transform and Fourier cosine transform. Now basically transformation means changing of a function. So in Fourier transforms, it is a mathematical technique that transforms a function of a time f of t to a function of frequency f of omega. Okay, and it is very closely related to Fourier series. This is somewhat similar to your Fourier integral, which we have dealt about in our first video. So the formulas are much similar. Earlier there is only a very slight difference between those formulas, so be careful that you don't get confused between those formulas. Okay, so we'll see the formulas one by one. First, we'll study about Fourier transform of a function f of x. It is denoted by capital F of x. Fourier transform, it is denoted by capital F of x, and it is defined as capital F of x is equal to 1 by root of 2 pi integral of minus infinity to infinity f of x e raised to minus I omega x dx. Okay. Similarly, we have got two more formulas. Fourier cosine transform. It is denoted by fc of f of x, which is defined as root of pi by 2 a omega. Now we are familiar with the notation a omega. We have studied it in Fourier integrals. The same formula comes here. So this will become root of pi by 2 into 2 by pi integral 0 to infinity f of x cos omega x dx. So on the whole, the formula is fc of f of x is equal to root of 2 by pi integral 0 to infinity f of x cos omega x dx. So either you can remember this formula, or else it is enough if you remember it is equal to root pi by 2 a omega, since a omega we have already studied it in Fourier integrals. Okay. Now Fourier sine transform of a function f of x, it is defined as fs of f of x, which is equal to root pi by 2 b omega. B omega also we have studied it earlier, that is 2 by pi integral 0 to infinity f of x sine omega x dx. So the formula now becomes root of 2 by pi integral 0 to infinity f of x sine omega x dx. Okay. So the main tips to remember these formulas are, now cosine transform contains the cos term, sine transform contains the sine term, whereas in Fourier transform e raised to minus I omega x is the term. Okay. Now considering the limits, for Fourier transform we have got the limits from minus infinity to infinity, whereas for both cosine and sine your limits are from 0 to infinity. Okay. Now we'll see one problem. Your question 1, that is Fourier cosine and sine transform needs to be found. Your function is given as f of x is equal to k for 0 less than x less than a, 0 for x greater than a. Okay, so the function exists only in the interval 0 to a, and that function takes the value k. Okay, so either you can go back to your formulas and see it once more. Okay, we'll see the answer. So we have to find both Fourier cosine transform and Fourier sine transform. Now let us consider Fourier cosine transform first. fc of f of x, it is defined as root of 2 by pi integral 0 to infinity f of x cos omega x dx, isn't it? Now instead of f of x we can substitute what here? K, because the function given is k. Now function takes the value k where? Only in the interval 0 to a. So the integral 0 to infinity gets replaced by 0 to a. Okay, so that becomes root of 2 by pi integral 0 to a k into cos omega x dx. Okay, so since k is a constant, you can take that k outside the integral. What remains? You need to integrate cos omega x. It is with respect to x. So the integration becomes sine omega x by omega within the limit 0 to a. When you integrate it, you get 0 to 2 by pi, root 2 by pi k into sine a omega by omega. Okay, now similarly Fourier sine transform, how can we find? First we'll write the formula. So you can either remember the formula using b omega or straight away write the formula root of 2 by pi integral 0 to infinity f of x sine omega x dx. Here also your f of x function gets replaced by k, and function takes the value k only in the interval 0 to a. So your integral limit becomes 0 to a. Since k is a constant, you take that k outside. You integrate sine omega x. Integral of sine omega x is minus cos omega x. Since the integration is with respect to x, this becomes minus cos omega x by omega within the limit 0 to a. Okay, you apply the limit and get the answer. Okay, so that's it. So that was for finding Fourier sine transform and Fourier cosine transform. Now we'll move on to the next problem. Your second question is, find the Fourier transform of f of x is equal to e raised to minus ax for x greater than 0, 0 for x less than 0. Okay, so here also the function exists only when x takes the value greater than 0, and the value is e raised to minus ax. So just recollect the formula for Fourier transform. What are the tips that I told you to remember the formula for Fourier transform? Integral limit will be from minus infinity to infinity, and the term will be e raised to minus I omega x, isn't it? Okay, so we'll go on. See the formula for Fourier transform. Capital F of x is equal to 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Okay, now in the next step, in place of f of x, we will be substituting e raised to minus ax, and that function takes the value e raised to minus ax only for x greater than 0. Therefore, x greater than 0 means x takes the value 0 to infinity. So the limit minus infinity into infinity changes to 0 to infinity. Only for positive values the function takes the value e raised to minus ax. Okay, so the formula now becomes 1 by root of 2 pi integral 0 to infinity e raised to minus ax into e raised to minus I omega x dx. Now how will you integrate these two functions? Both are same functions, exponential functions, isn't it? So when exponential functions are multiplied, what will happen? We'll add the powers, isn't it? When the powers are same, we can add the powers. Okay, so that term becomes e raised to minus a minus I omega into x. X is taken common since both the terms are having x. So x is taken common outside. Term becomes e raised to minus a minus omega into x dx. Now when you integrate it with respect to x, what will happen? 1 by root 2 pi is the constant that remains outside. E raised to minus a minus I omega x by minus a minus I omega. That is a coefficient for x. So that comes in the denominator. Apply the limit 0 to infinity. Okay, so when you apply the limit infinity, you have to make sure what is e raised to minus infinity. E raised to minus infinity is 0. You should know that value. E raised to minus infinity is 0 and e raised to 0 is 1. So when you apply those results, we will get the final answer as 1 by root of 2 pi a plus I omega. Okay. 1 by root of 2 pi a plus I omega. That is a Fourier transform for your given function. Is it clear? Okay. So we will move on to the next problem. The third question is, find the Fourier transform of f of x is equal to e raised to minus mod x, where x takes the value between minus infinity to infinity. Okay. So see the question. It is not a direct question. Your function contains a modulus x term, e raised to minus mod x. So here again you will have to know about your modulus function. What do you know about the modulus function? See, I have written in the side. Modulus of x takes the value x for x greater than 0 and minus x for x less than 0. Okay, modulus of x is equal to x for x greater than 0 and minus x for x less than 0. Okay, now here we have to find Fourier transform. We'll write down the formula first. Capital F of x is equal to 1 by root 2 pi integral minus infinity to infinity e raised to minus mod x e raised to minus I omega x dx. Okay, now we can directly integrate it since it contains a modulus term. We know modulus x has two different values. For positive values it will be taking the value x, and for negative values it will be taking the value minus x. So we are going to split the integral minus infinity to infinity into two integrals, that is minus infinity to 0 and 0 to infinity. Okay, so first integral, that is from minus infinity to 0, means that is a negative integral, isn't it? It takes negative values. Now mod x takes what value for negative values of x? Minus x. So when you substitute, this will become e raised to, minus is already there in the question, in place of mod x again you will be substituting minus x, that is minus of minus x, okay, into e raised to minus I omega x dx, plus next integral 0 to infinity, that is positive values. For positive values mod x takes the value x, so that will become e raised to minus is already in the question, in place of mod x you will be substituting x, positive value x, so that will become e raised to minus x e raised to minus I omega x dx. Okay, now just as in the previous problem, since both are exponential functions, you will be adding those powers, so it will become 1 by root 2 pi integral minus infinity to infinity e raised to, x is common, x is taken outside, 1 minus I omega dx, plus integral 0 to infinity e raised to minus x is taken outside, 1 plus I omega dx. Okay, so in the next step this will be equal to 1 by root 2 pi integral, you are integrating e raised to x. What is the integral of e raised to ax? E raised to ax by a, the coefficient of x. So that same thing is applied here, e raised to x into 1 minus I omega by 1 minus I omega within the limit minus infinity to 0, and e raised to minus x into 1 plus I omega by minus of 1 plus I omega within the limit 0 to infinity. Okay, now apply the limit 0, infinity and minus infinity. Remember the results, e raised to minus infinity is 0 and e raised to 0 is 1. When you apply those results, and finally you will be getting the answer root 2 by pi 1 by 1 plus omega square. Okay, just don't read through the problems, write it down, see whether you're getting the answers. Okay, yes.